All right, our last learning target is performing operations with complex numbers. So sometimes we're going to have a parabola that's not going to have any real solutions, okay? When you see this graph, that might be a parabola that opens up, that's above the x-axis, or it could be a parabola that opens down underneath the x-axis, okay? So, for example, we've also talked about using the quadratic formula and what happens when you take the square root of a negative number, okay? So we cannot find a real solution, but there is still a solution. So we need to talk about how to write a solution that is not a real solution. So we've got 4 vocabulary words. Let me just kind of go through these really quick and then you can write them down once I'm done. So the imaginary unit is the letter I. Okay, and this is defined by the fact that I squared equals -1 or that I equals the square root of -1. Okay, so those two facts go together, right? If you have I squared equals 1, you square root each side, you'll get I equals square root of -1. Okay, so we can find I by doing the square root of -1. So for example, let's say I wanted to write down the square root of -20, right? That would be the same as I times the square root of 20. That basically pulls the -1 out. In other words, this would be the same as the square root of -1 times the square root of +20. Square root of -1 can be rewritten as I. I actually think on this one, and I'll get back to you on this, I think you'd actually put the I second. So just be careful that it doesn't look like it's under the square root. It's kind of like a coefficient and a variable. Okay? So that's the basics of an imaginary unit. A conjugate pair is a basic idea, and it's going to be useful in imaginary terms. So a conjugate pair is 2 expressions, a pair of expressions, in which one is the sum of 2 terms and the other is the difference of the same terms. So my example of that is x plus 3 and x minus 3. Those are called conjugate pairs. And what's special about conjugate pairs, if you think about this example, is that if I multiply these, I'm going to end up with no middle term. Oops. Because these will cancel, and I'll have x squared minus 9. Okay, so that's what's special about a conjugate pair. And so this is where it's going to come in useful when we do complex conjugates. Basically, a plus bi and a minus bi. This is where we've got the product, and what's going to end up happening when you have the product of a plus bi and a minus bi. Those are called complex conjugates. You're going to actually end up with a product that produces a non-zero real number. So basically you multiply those two together and you'll end up with a real number. So it's a way to go from imaginary to real, okay? And then lastly, the word complex. A complex number is in the form a plus bi, where a and b are real numbers and I equals the square root of -1. So I kind of already did that here. This would be kind of like the bi term, where you have the real number coefficient and then I for the imaginary part. So basically complex numbers are examples kind of like this, where you've got 3 plus 4i, you've got 2i, 5/4 -3 minus I times the square root of 2. We've got all of these complex numbers, and actually when I'm looking at this now I do remember that the I goes in front. So when I go back to this example here, actually should get rid of this. We put the I in front of the square root. Sorry about that. Got all the complex numbers. Complex numbers contain all real numbers and all imaginary numbers. Okay, so then from there you can break it down into the real parts and the imaginary parts. Those would be the parts where you're taking the square root of a negative number or where you have the letter I in there. And then real numbers, to review, can be broken down into rational numbers and irrational numbers. And then we've got a subset of that. We've got the integers and then the natural numbers. All right, so if I was going to solve this, I would subtract 3, and I'd have x squared equals negative 3. Okay, and then I'm going to take the square root of each side, and I'll have x is equal to the square root of negative 3, which then I can write as x equals I times the square root of 3. So that's how you write your answer as an imaginary number. Okay, this one here, I'm not gonna be able to factor it. Just off the top of my head, I know that I wrote it so you can't. So we're gonna use the formula. We're gonna do 10, negative 10 squared minus 4 times 1 times 31 divided by 2 times 1. Okay, we're gonna end up with 10, and let's just do, oops, 100, because I know that's what 10 squared, negative 10 squared will be, minus 4 times 31. Don't even need to have the 1 in there. So I'll have a negative 24 underneath the square root. That's how we know we're going to have a non-real answer, because you cannot take the square root of a negative and have a real solution, okay? And so what I'm going to do here is we're going to practice a couple things. So first of all, I'm going to take and I'm going to make this a number with I. My goal here, sorry, is to have it of the form a plus bi and a minus bi. Okay, so I'll have 10 plus I root 24 divided by 2. And let's see, I wonder if I can reduce 24. And what I remember is that if I need to reduce the square root of 24, I can think of perfect squares that go in there. So if I have this, that would be the same as the square root of 24. So 2 root 6 is the same as this. So what I see is that actually each term is going to be divisible by this 2. So I'll have this. So really this is going to cancel out, and this is going to be 5. And I forgot we have a minus in there. So my two answers are 5 plus I root 6 and 5 minus I root 6. There's my two answers. And we can go through this in class here, but basically if I were to take these factors and I were to multiply them out, like I said, since they're complex conjugates, we'd actually end up with all real numbers. So just something to kind of connect back to the beginning. So we've got our two solutions here. These are actually your x's. Okay, so simple before class problem here. All you need to do is just convert negative 18 into a complex number.